In 2017, something from beyond our solar system broke every rule we thought applied to space rocks. A long, needle-like object shot through space at over 50 miles per second, accelerating in ways that defied every known explanation. No glowing tail, no comet-like haze, just a dark shard spinning wildly across the night sky, moving faster than anything we had ever recorded from within. But that was only the opening chapter. What began with this strange visitor set the stage for building the most advanced skywatching system humanity has ever created. And in July 2025, that network revealed something even more astonishing, an object that made the first discovery look almost ordinary. Join us on this cosmic investigation. Like and subscribe to witness the mystery. Let's begin. October 19, 2017. Was a turning point in our understanding of interstellar travel. On the summit of Haleakala in Maui, astronomer Robert Werrick was scanning images taken by the Pan-STARRS telescope, looking for the usual faint dots that move between the stars. At first glance, it seemed no different from thousands of other space rocks drifting through our cosmic neighborhood. But then the data came in. This object was racing at 96,000 miles per hour, nearly 54 miles every second. To put that speed in perspective, imagine a bullet fired from New York reaching Los Angeles in just about a minute. That impossible velocity told astronomers one thing immediately. This was no ordinary asteroid or comet. It had to have come from outside our solar system. Nothing born here moves like that. Most comets and asteroids cruise at a calm 12 miles per second on average. This interstellar intruder was traveling nearly 5 times faster, meaning it had spent millions or even hundreds of millions of years drifting between the stars before it crossed paths with us. It was given a Hawaiian name, one that translates to a scout, a messenger from afar, fitting for the first of its kind. But the surprises didn't end with speed. As observatories around the globe tracked it, something bizarre appeared. The object was tumbling end over end like a spinning baton, and every 7.5 hours its brightness changed dramatically. This revealed it wasn't shaped like the usual potato-like asteroids or compact icy comet. Instead, the light variations suggested something 10 times longer than it was wide. Picture a skyscraper laid flat, flipping endlessly through space. Nothing we had catalogued in our solar system came close to that level of elongation. To some, it resembled a shard of cosmic metal, a splinter from an unknown origin. To others, it raised the possibility, however far-fetched, of artificial construction. But the real puzzle wasn't just its strange shape. What came next challenged the very physics astronomers relied on. The Pan-STARRS telescope system is like a giant cosmic lookout, sweeping the skies each night for any sign of danger. Most nights, it captures the usual suspect: main belt asteroids between Mars and Jupiter, the occasional comet wandering in from the Kuiper belt, or small near-Earth rock that require careful tracking. But that night was different. The automated system flagged something unusual, and soon astronomers were staring at data they could hardly believe. The faint dot wasn't orbiting our sun. It was passing through, just a traveler on a one-way journey. When its path was traced back, it appeared to have come from the direction of the bright star Vega in the constellation Lyra. But there was a problem. It had taken nearly 300,000 years to reach us. Vega wasn't even in that position when the journey began. This object had been adrift long before humans existed, roaming interstellar space while our ancestors were still painting caves and shaping stone tools. For decades, astronomers suspected that interstellar rocks must exist. Other star systems, just like ours, fling out asteroids and comets during gravitational encounters with giant planets. The math was solid, but catching one was like trying to find a single grain of sand on Earth's beaches. And yet here it was, the first confirmed wanderer from another star system. Telescopes worldwide locked on, and each new measurement only deepened the mystery. Its surface reflected a dark red hue, scarred by eons of exposure to cosmic rays and violent stellar explosion. This coloring revealed an ancient history, perhaps older than our solar system itself. While Earth was still being pummeled by asteroids 4 billion years ago, This object may have already been drifting silently through the void, carrying secrets from a long-lost home star. But what really fascinated scientists was the way it reflected light. Instead of behaving like a round or irregular rock, it flickered like a cosmic beacon, its brightness swinging by more than 2.5 times as it rotated. No known asteroids stretched to such extreme. Some suggested it might be a fragment from a catastrophic collision in another star system, a long splinter thrown into the galaxy after two massive bodies smashed together. Others speculated it could be made of exotic ices, like hydrogen ice formed in the frigid depths of interstellar clouds. If true, it could have been reshaped by sunlight as it neared our star, sublimating into its elongated, needle-like form. But there were problems. The surface reflected more like rock or metal, not ice. Its dark red tint suggested it had weathered cosmic radiation for millions of years. Something fragile ice would never have survived. That led to the boldest theory of all. Perhaps it wasn't natural at all. Perhaps it was a relic, a piece of alien technology or debris from a civilization far beyond our own. Mainstream science remained skeptical, but no one could deny that this object was rewriting what we thought we knew. The speed alone was extraordinary. At nearly 200,000 miles per hour, it was racing through the solar system like a sports car on a highway of slow-moving traffic. Even our fastest spacecraft, using planetary slingshot, barely reached 40 miles per second. This thing was cruising at over 50,000 stoppable after millions of years of travel. And because of that speed, astronomers had precious little time to study it. By the time it was first observed, it had already made its closest pass to the sun. It was on its way out, fading into the dark. The race was on. Observatories across the globe, from Hawaii to Chile to South Africa, scrambled to collect every possible piece of data. Radio telescopes listened for signs of transmissions, while infrared sensors scanned for heat that might reveal its composition. For weeks, the world's most powerful instruments were turned toward this single visitor. Then, in June 2018, a revelation stunned the scientific community. Marco Micheli and his colleagues at the European Space Agency discovered that the object wasn't following the path gravity predicted. It was accelerating. Not much, but enough to be unmistakable. Like a marble on a perfectly flat table suddenly nudged by an invisible finger, this rock, or whatever it was, seemed to have its own source of propulsion. The push was incredibly faint, about the same as a soft breath of air on your skin. But in the frictionless vacuum of space, it was enormous. Normally, this kind of acceleration is caused by outgassing, when comets approach the sun and their ice is vaporized, releasing jets of gas that act like natural rocket thrusters. But this object showed no cometary tail, no halo of gas, no dust streaming into space. Even the most sensitive instruments found nothing. To explain the acceleration, it would have needed to vent enormous amounts of material, which would have lit up telescopes with a brilliant coma thousands of miles wide. Instead, all they saw was a dark, silent shaft. Scientists scrambled for explanation. Maybe it was venting carbon particles invisible to our instrument. Maybe the jets of gas were firing in narrow streams pointed away from Earth, making them undetectable. Or perhaps something even stranger was at work. Some proposed that sunlight itself was providing the push pressure from photons hitting an object so thin and lightweight it behaved like a solar sail. If true, this would mean the object had the density of foam or the engineering of a spacecraft. Whatever the truth, this cosmic messenger had forced humanity to confront mysteries we were not prepared for. And it was only the beginning. Sunlight doesn't just bring warmth and light. It also carries momentum. When photons bounce off a surface, they exert a minuscule push. For most space rocks, this pressure is completely drowned out by the overwhelming pull of gravity. But if an object has just the right balance of size, shape, and density, this gentle stream of radiation can create noticeable acceleration. That possibility sparked one of the most divisive theories ever proposed about this mysterious interstellar wanderer, an idea that split scientists and captured headlines worldwide. Normally, comets follow a predictable story. Born in the icy outskirts of a star system, they spend billions of years frozen solid until one day their path carries them close to a sun. That sudden warmth This object was venting material in an entirely new way, or something else altogether was pushing it. For interstellar travel. Could this be a relic of extraterrestrial engineering? crash, disrupt one observatory. The other site seamlessly. This same network would stumble upon a discovery that reshaped our understanding of interstellar. Time in history, astronomers were watching a fully active interstellar comet perform systems across the galaxy may build themselves in strikingly similar ways. Still, it shifts the frequencies of any radio emission. Receivers must constantly retune to keep up, like Humanity will never see it again. For our civilization, this is a singular window into a distant stellar asteroid and perhaps dozens of interstellar visitors per decade. Meanwhile, space Planetary defense networks extend far beyond this single mission. The same technologies protect Earth from dangerous asteroids, capture the explosions of distant supernovae, and track satellites orbiting overhead. The algorithms sharpen not only astronomy but fields as varied as medicine and robotics. Most importantly, these interstellar messengers have rewritten our perspective. We now know the Milky Way is not a collection of sealed-off worlds, but a living system of exchange. Our sun both receives and contributes, sending its own comets outward, while welcoming wanderers from elsewhere. What began with one puzzling visitor has grown into a new era of exploration. Soon, advanced surveys will find these objects routinely, building catalogs of alien material too distant for spacecraft to ever reach. Each new detection is another voice from across the stars, carrying secrets of worlds unseen. The cosmos, it turns out, comes to us, one interstellar traveler at a time.